Earlier this year, the northern lights were visible to much of the country. As the vivid colors were seen all the way down to Texas, people across the country were able to witness part of how the Earth's magnetic field protects us from energized particles from the sun. So this morning, our Seattle station has a look at how scientists are now getting more precise data to predict solar storms.
The Space Weather Prediction Center actually went online in the mid-2000s. This was when we realized how much space weather impacts the technology we use every day. NOAA runs it along with 8 other environmental prediction centers. Space weather was largely unknown before the space age. The Earth's atmosphere does such a good job of protecting us that we were mostly unaware of what was happening in the space around us. But as soon as the satellites started flying in the late 1950s, discoveries began. The earliest satellites discovered unknown belts of high-energy radiation surrounding the Earth, and Mariner 2 confirmed the existence of the solar wind for the first time in 1962.
Once we decided we were going to put people up there, it became important to know a lot more about that environment.
As late as the mid-1990s, we had no satellites that continuously monitored the sun from above the atmosphere. This seriously hampered our ability to forecast solar storms. It would be like trying to understand our earthly weather by occasionally taking measurements inside your house. Finally, around the turn of the century, many new spacecraft were launched to observe the sun continuously and from many angles. These led to the discovery of coronal mass ejections, or CMEs, that can trigger geomagnetic storms. Currently, there are about 19 sun-observing spacecraft. Some are even parked between the Earth and Sun to give us an early warning about approaching solar storms.
One of the greatest things has been the development of what's called a coronagraph. So you can think of it, again, like a revolution with the radar, with the introduction of Doppler, because in the early days, we couldn't see those coronal mass ejections come off the sun, or at least not very well.
Right now, we can forecast geomagnetic storms about 1 to 4 days before they reach the Earth. But sometimes we have trouble determining how hard they'll hit the Earth's atmosphere. This makes it difficult to judge how strong the storms will be.
We can't track it until it hits a satellite that's about 1 million miles from Earth at the L1 Lagrange point. And when it hits that, we get our first look at the magnetic field and its orientation, and then it's just unfolding as it passes. So, but we can see at least how, the magnitude, how far south it goes, because that's the component that matters.
Today, space probes are flying closer to the sun, gathering ever more precise information. The Parker Solar Probe has flown through the sun's 2 million degree atmosphere of the corona, and in 2023 it was blasted by a CME and survived. These observations, combined with others, are finally helping us build computer models. These will allow us to forecast and prepare for space weather events just like we do for storms down on the surface of the Earth.